A reference angle is a non-quadrantal angle in standard position. What we can do with a reference angle is, just like with a reference triangle, we can draw from any point on the terminal side back up or down to the x-axis, and the reference angle would be that measurement from the x-axis to the terminal side. So example 3 says find the reference angles, sketch each angle, then find its reference angle. So sketch a 210-degree angle. So draw on a set of axes a 210-degree angle. From here to here would be 90, then 180, and then a little bit past 180 would be where my terminal side would be, but how much past 180 would be the terminal side? So if that's a 210-degree angle and to the other side of the x-axis is 180 degrees, I've gone 30 degrees past 180 degrees. So my reference angle would be the 30-degree angle. Part B has you define the reference angle to negative 5 pi over 4. For right now, I think it might be best for you to change negative 5 pi over 4 to degrees. So to change that to degrees, we're going to replace the pi with 180 degrees. So this would be negative 5 times 180 divided by 4, or negative 900 over 4, which is negative 225 degrees. Should be a negative right in there, negative 225 degrees. Now, which way does negative 225 go? Negative 225 goes clockwise. Negative angles go clockwise, so that's negative 90, negative 180. I don't want to go all the way up to the y-axis because that would be negative 270, but 45 degrees past the x-axis would be negative to negative 225. So that would be a negative 225-degree angle, which means my reference angle would be 45 degrees. Now, we would still say the reference angle is a positive measurement. So the reference angle is 45 degrees. But since they gave us the information in radians, let's go ahead and change 45 degrees to radians. So remember, the way to change degrees to radians is it's going to be 45, the number of degrees, times pi divided by 180. And 45 over 180 reduces to 1/4, or in other words, pi over 4. So in radians, that reference angle is pi over 4. So have you noticed that our answers on this particular question was 30 degrees, and before we changed it back to radians was 45 degrees? If you recall from section 9.1, those measurements have importance in trigonometry. From section 9.1 are special triangles. We had two special triangles. They were special because of the measures of their angles, and the measures of their sides were fairly simple to remember. So we have the 30-degree, 60-degree triangle with measures of 1 for the short leg, square root of 3 for the long leg, and 2 for the hypotenuse. And then we had the 45-degree triangle, and the measures of the 45 legs were measures of 1 with a hypotenuse of the square root of 2. We can find the exact value of a trig function if the reference angle is 30 degrees, 45 degrees, or 60 degrees. So example 4 says find the exact value of each trig function. It's a cosine of 240 degrees. So let's go ahead and draw out a 240-degree angle to find the reference angle for that. So 240 degrees would be 90, 180, and I'd need to go 60 degrees past 180 to get to 240. So that is a 240-degree angle. And then I can draw a reference triangle back up to the x-axis. So I'm going to blow up that triangle to make it a little bit bigger and easier to see. So my reference angle is 60 degrees right there. This side, well, it is going to the left. For my reference triangle, it's going to the left. So this measurement, being opposite of the 30-degree angle in that triangle, is going to have a measure of, and you go over to our special triangle, we'll say it has a measure of -1. And this side is going downward. It's opposite of that 60-degree angle, so it's going to have a measurement of the negative square root of 3. And the hypotenuse, remember, hypotenuse will always be positive, and that's going to have a measure of 2. So we're trying to find the measure of a reference, or the cosine of a 240-degree angle, which means we're going to use a 60-degree reference triangle to figure that out, using those negative measurements. So the cosine of a 240-degree angle, formula for cosine is adjacent over hypotenuse. The adjacent side is the -1, and the hypotenuse is 2, which means the cosine of 240 degrees is -1/2. If you type cosine of 240 into a calculator, it will tell you that it has a measurement of -0.5, which is the same as -1/2. Finally, we can use trigonometry to solve real-world problems. The swing arms of the ride at the right are 84 feet long, and the height of the axis from which the arms swing is 97 feet. What is the total height of the ride at the peak of the arc? And this ride, it kind of reminds me of what they call the giant barn swing at Silver Dollar City. And if you don't know what the giant barn swing at Silver Dollar City is, here's a video of it. Looks pretty fun, doesn't it? So in order to figure out how high the barn swing goes, we need to use trigonometry. So the swing arms is right here, and it is indicative of the terminal side. We'll still use our initial side in the same position as it normally is. And notice it creates a -200-degree angle. So if I were to place that on a coordinate plane without all the pretty pictures there, it would look like this. So what is the measure of my reference triangle from here to here? From here to here is 90. Then to 180, and then this is going to be 20 degrees past that. So that's 20 degrees, so I'm going to blow that triangle up so you can see it easier. 20-degree angle right there. Here would be the right angle, and the length of the swing itself is 84 feet. So to figure out how high the swing goes, we're trying to figure out the y side. And 20 degrees is not one of our special triangles, but we can use the same trigonometry we also did in section 9.1 by using a calculator to figure out the proper trig measure, or trig function of 20 degrees to help solve for y. So notice we're trying to solve for y, which is opposite of my reference angle. And notice that 84 is a hypotenuse. Which of our trig functions was opposite and hypotenuse? The most commonly used one that's opposite and hypotenuse is sine. The formula for sine is opposite over hypotenuse. So we're going to take the sine of my reference angle, 20 degrees, sine of 20, and set it equal to the opposite side, which is the y, over the hypotenuse, which is 84. Going to a calculator, the sine of 20 is going to be equal to about 0.3420. And then to solve for y, I just got to multiply both sides times 84. And I get an answer of approximately equal to 28.7 feet. So the measure of y is 28.7. So how high does the swing go? Well, that 28.7 is measured from the x-axis, which is 97 feet above the ground. So we would have to add those two together. So 28.7 plus 97 gives you a grand total of 125.7 feet. So that swing gets pretty high.